Hello and welcome to this episode of my tutorial video series. In this video we shall discuss point elasticity of demand, a subtopic in elasticity of demand of demand theory in microeconomics. Now we know price elasticity of demand is the responsiveness of quantity demanded as a result of change in price. That means when price of a commodity changes, how the consumer responds to that change in terms of his or her consumption of that commodity. So mathematically speaking, price elasticity, in short we write E suffix P equals to percentage change in quantity demanded divided by percentage change in price. Now elasticity or price elasticity of demand is a big subtopic, and in my other videos I have discussed the different types of elasticities, that is price elasticity, income elasticity, cross elasticity, etc. So this video will focus only on point elasticity of demand, and other discussions on elasticity are done in other videos. So price elasticity is equal to percentage change in quantity demanded divided by percentage change in price, that is equal to change in quantity demanded by original quantity demanded whole divided by change in price divided by original price. Now this has been discussed in my other videos, but for a quick recap I have written this. So price elasticity equals to change in quantity demanded by original quantity demanded whole divided by change in price by original price, that is equal to delta Q by Q divided by delta P by P, right? That is equal to delta Q by Q into P by delta P, P by delta P equals to P by Q into delta Q by delta P. Now there are different methods of determining price elasticity of demand: outlay method, point method, average method, etc. In this video we will discuss only the point elasticity of demand, that is how to measure the elasticity on a particular point of the demand curve. Suppose on x-axis we measure quantity and on y-axis we measure price. Suppose this is the demand curve. Say AB. AB is the demand curve. we have to find out the price elasticity on a certain point, say at this point. Say this is equal to this point is R. So at point R, the consumer is consuming, say, OM units and price is P. Correct? Now, EP equals to P by Q into delta Q by delta P. Right? EP equals to P by Q into delta Q by delta P. P equals to original price delta P equals to change in price, Q equals to original quantity, and delta Q equals to change in quantity. Correct? So here P equals to OP and Q equals to OM. Original price and original quantity. Correct? Into delta Q by delta P. Now notice very carefully. What is delta Q by delta P? Delta Q by delta P equals to 1 by delta P by delta Q. Isn't it? Delta Q by delta P equals to 1 by delta P by delta Q. Now what is delta P by delta Q? Delta P by delta Q is the slope of the demand curve. This is the slope of the demand curve. Delta P by delta Q equals to slope. So delta Q by delta P equals to 1 divided by slope. One divided by the slope equals to OP by OM into 1 by, now what is the slope of the demand curve? MY by MB. It is tan of this angle. So 1 by MY by MB equals to OP by OM into MB by MY. Now my equals to OP. So in place of my we can write OP. So this is equal to OP divided by OM into MB divided by OP. OP is equals to my. OP cancels out each other in numerator and denominator. So what remains? Remains MB divided by OM. MB divided by OM. Now consider a right angle triangle. In a right angle triangle, if a perpendicular is drawn from the hypotenuse on the base, this is hypotenuse, this is base, and this is P perpendicular. So when a perpendicular is drawn from any point on hypotenuse on the base, then that line cuts the hypotenuse and the base in same ratio. That means this divided by this will be equal to this divided by this. This is a property of right angled triangle. Therefore MB by OM equals to RB by AR. RB by AR. This is property of right angled triangle. In a right angle triangle, ABO is a right angle triangle, and RM is a perpendicular from point R which is on AB, that is hypotenuse. RM is perpendicular on OB, that is base. So RM is bifurcating AB and OB in same ratio. So MB by OM will be equal to RB by AR. So we can conclude that elasticity on a point of the demand curve is equal to the lower segment, because RB is the lower segment and AR is the upper segment. So the elasticity at point R is lower segment by upper segment, or for that matter, elasticity on any point of the demand curve is equal to the lower segment of the demand curve divided by the upper segment of the demand curve. So this is lower segment divided by upper segment of demand curve. So elasticity at any point on the demand curve is equal to the lower segment of the demand curve divided by the upper segment of the demand curve. Now say this is the demand curve. Say AB, on x-axis we measure quantity and on y-axis we measure price. Suppose this is the middle point, midpoint of the demand curve AB. These are two extreme points of the demand curve, A and B. Say this is R. At point B, EP equals to lower segment by upper segment, that is 0 by AB. There is no lower segment at point B. So 0 by OB. Sorry, 0 by AB. The full part is upper segment equals to 0. So elasticity at point B is 0. At this point, EP equals to lower segment, the whole of the demand curve is the lower segment as regards point A. In the context of point A, whole AB is the lower segment. And how much is upper segment? 0. That is AB by 0 equals to infinity. So in these two extremes of demand curve, at one point elasticity is 0, that is at that point where the demand curve is intersecting intersecting x-axis, elasticity is 0. And at point A, that is where the demand curve is intersecting or touching y-axis, elasticity is infinity. Now if R is the midpoint, this means OB equals to OA, OB equals to, sorry, not OB, RB equals to AR, RB equals to AR. Therefore, at point R, EP equals to 1, because RB by AR is 1. Correct? At any point in between R and B, it can be here, it can be here, it can be here. At any point in between R and B, lower segment is lesser than the upper segment. Say at this point, say this is point K. At point K, lower segment is less than upper segment. So at any point in between R and B, EP is less than 1, because at any point here or here, lower segment is lesser than upper segment. So in between R and B, EP is less than 1. Now in between R and A, at this point or this point or at this point, you see, for all these points, the lower segment is more than the upper segment. Say at this point, say this is point N. So at point N, NB is the lower segment and AN is the upper segment, and NB is greater than AN. So at any point in between A and R, EP is greater than 1. Right? So as one moves down the demand curve from point A to B, elasticity falls from infinity to 0. At the midpoint, that is at point R, lower segment is equal to upper segment. So at point R, EP is 1. at any point in between R and B, the lower segment is lesser than the upper segment. So elasticity at any point in between R and B, EP is less than 1, elasticity is less than 1, and at any point in between A and R, lower segment is more than the upper segment. So elasticity at any point in between A and R is greater than 1. Correct? So here we have learned how we can calculate the point elasticity of demand, that is the elasticity, price elasticity at any point on the demand curve. Now here we have taken a linear demand curve that can be non-linear too. The demand curve can be non-linear too, like this, and we can do the same thing. We draw a tangent. This is the demand curve, non-linear. We draw a tangent at that point on which we have to calculate the elasticity, and then again we calculate lower segment by upper segment. So this lower segment by upper segment logic applies to straight line demand curve as well as non-linear or curvilinear demand curve. Right? When the demand curve is curvilinear, we draw a tangent at that point on which we are going to calculate the elasticity, and taking that straight line, that tangent, we calculate the lower segment and upper segment and divide lower segment by upper segment, as we have done in case of straight line demand curve. So we have shown geometrically how the point elasticity is arrived at. EP is equal to P by Q into del Q by del P. That is the original formula of price elasticity. That is percentage change in quantity demanded divided by percentage change in price. This is the formula of price elasticity of demand. So we get EP equals to P by Q into delta Q by delta P. Now consider this figure. Here AB is the demand curve, P is the price, that is OP is the price. So we have to measure the elasticity at point Y, that is at price OP the consumer is consuming OM units of the commodity. So the point is, what is the elasticity at point R? So elasticity equals to P by Q into del Q by del P. Now what is P? P is original price. We put original price OP. Q is original quantity. We put original quantity OM. Delta Q change in price. Sorry, delta Q change in quantity. Delta Q, delta P change in price. Now delta Q by delta P is 1 by slope of the demand curve. 1 by slope of the demand curve. Why? Because slope of the demand curve is dP by dQ. This is the slope of the demand curve. Delta P by delta Q. So we have written here OP by OM into 1 by slope, that is OP by OM into 1 by, what is the slope of the demand curve? that is tan of this angle, tan of RBM okay, that is my by mb perpendicular by base, mr by mb correct. So you get OP by OM divided by MR by MB, right? MR by MB. So OP by OM into MB by MR MR is equal to OP. So OP by OM into MB by OP cancel out each other. So what remains? Remains MB by OM. MB is capital B, not small b. I have written capital B, so it will be capital B. MB by OM. Now MB by OM, this by this will be equal to this by this, because this is property of the right angle triangle. In a right angle triangle, if a perpendicular is drawn from the hypotenuse on the base from any point on the hypotenuse, this is H hypotenuse. So if we draw a perpendicular from any point of the hypotenuse on the base, that straight line will bifurcate hypotenuse and base in the same ratio. This means this divided by this equals to this divided by this. Therefore, MB by OM equals to RB by AR. Now RB means the lower segment of the demand curve, AR means the upper segment of the demand curve. So the price elasticity of demand at any point on the demand curve is equal to the lower segment of the demand curve divided by the upper segment of the demand curve in the context of that point. So at point R, this is RB by AR. Now consider this figure, this diagram. A and B are two extreme points of the demand curve AB. Elasticity at point B equals to lower segment of the curve divided by upper segment. There is no lower segment, that is lower segment is 0. 0 by AB, lower segment. AB is the full demand curve, which is the upper segment. So AB equals to 0 by AB equals to 0. So elasticity at this extreme, that is where the demand curve touches the x-axis, is 0. On the other extreme, that is at point A, where the demand curve touches the y-axis, the full demand curve is the lower segment. There is no upper segment, that is upper segment is 0. So elasticity at this point equals to AB divided by 0. This means infinity. So elasticity at point A is infinity, whereas elasticity at point B is 0. In between A and B, elasticity varies from 0 to infinity. If R is the midpoint of the demand curve AB, then elasticity at R is equal to RB by AR. Now R being the midpoint, RB will be equal to AR. Therefore, at this point, elasticity will be equal to 1. Elasticity at any point in between R and B will be less than 1. Why will be less than 1? Because in the context of any point in between R and B, lower segment is less than the upper segment. So EP is less than 1. And for any point in between A and R, the lower segment is greater than the upper segment. Say for example point N. NB is greater than AN. So at any point in between A and R, elasticity will be greater than 1, because for any point in between A and R, lower segment is greater than upper segment. So here elasticity will be greater than 1. Now what is true for a straight line demand curve is also true for a curvilinear demand curve or non-linear demand curve, as we have drawn here dd dash. Only thing is that the point at which we want to measure the PEICE elasticity, we have to draw a tangent. Say for example, on point M on the demand curve dd dash, we have to find out what is the elasticity. So we have drawn a tangent AB at point M. Then we take the lower segment by upper segment. So elasticity at point M is equals to MB by AM. That is lower segment divided by upper segment. Correct? Yeah. So here we have learned how to calculate the point elasticity of demand on a straight line demand curve and on a non-linear or curvilinear demand curve. So I think this is enough for this video. I hope you have enjoyed this video. Please send your suggestions, your comments, your queries, and once again I request you to like and subscribe our channel. Okay, and thank you for watching this video. Goodbye and stay well.